In today's video, we derive Bayes' rule and the law of total probability. Then, we use these concepts to work through a few example questions. The intersection of two events is defined using the cap symbol. It's the probability of two events happening simultaneously. To get this probability, we need to multiply the probability of event A happening by the probability of event B happening, conditional on event A. If A and B are independent, then we could just compute it as P of A cap B equals P of A times P of B. But we're assuming for now that they aren't independent. We can rewrite this relationship as P of A cap B equals P of A given B times P of B. Then, we now have two equations. We can combine these two equations to get P of A given B times P of B equals P of A times P of B given A. If we rearrange this formula for P of A given B, then we get P of A given B equals P of B given A times P of A over P of B, which is Bayes' rule. Bayes' rule is fundamental to many probability questions of varying difficulty. Now, let's walk through a simple example. A spam filter correctly identifies 98% of all spam emails. The probability of an email being flagged is 36.4%, and the probability of an email being spam is 30%. If the filter marks an email as spam, what is the probability that it's actually spam? For this problem, we can directly apply Bayes' rule. We know that the probability of an email being flagged, given that it is spam, is 98%. We also know that the probability of an email being spam is 30%. Finally, the probability of an email being flagged is 36.4%, so we can compute the probability of an email actually being spam, given that it's flagged. Now that we've learned and understood Bayes' rule, let's move on to the law of total probability. If I have three events that cover the entire sample space, B1, B2, B3, and an event A, I can compute the probability of event A occurring by computing and summing the individual probability subspaces for each event. Generally, we can express the law of total probability like so. Now let's move on to another example. In a certain town, 30% of drivers are teenagers, and the remaining 70% are adults. The probability that a teenage driver gets into an accident each year is 12%, while for adult drivers, it's 4%. What is the overall probability that a randomly chosen driver will get into an accident? Just as with the previous question, we start with what we're trying to compute, which is the probability that a driver will get into an accident. We can determine this value using the law of total probability. Let's try another example. Suppose we have two tennis ball factories. Factory A produces 60% of the tennis balls, and Factory B produces 40% of the tennis balls. 1% of the tennis balls from Factory A are flat, and 2% of the tennis balls from Factory B are flat. If I buy a tennis ball from the store, and it's flat, what's the probability it was produced by Factory A? To solve this problem, we can use Bayes' rule and the law of total probability. First, we start out with what we're being asked. We want to know the probability of a tennis ball coming from Factory A, given that it's flat. We can therefore arrange Bayes' formula like this. We know that 60% of balls come from Factory A. Next, 1% of tennis balls from Factory A are flat, so we know that the probability of a ball being flat, given that it came from Factory A, is 1%. Finally, we need to calculate the probability of a ball being flat. To do this, we utilize the law of total probability. Then, we sub this value back into our original equation. In this video, we learned about Bayes' rule, the law of total probability, and how to utilize these ideas to solve problems. Thank you for watching. Please subscribe for more content on probability, logic, and beyond.